Hello friends, how are you? In today's video, let us learn how to solve the problems related to electric potential. So we start with example number 1. As I already told you, in this video, I am going to solve ample of problems based upon electric potential. And so in this question, what is the question? Calculate electric potential at the surface of the nucleus whose radius is 6.55 into 10 raised to minus 15 meters and atomic number is 79. So here is a atom and it is a nucleus, and what is the Z value? Z value is 79. So the atomic number, what is the value of atomic number? That is 79. That means there are the 79 particles are present at the center, and the charge on single particle, charge E on the single particle is nothing but 1.6 into 10 raised to minus 19 coulombs. So there are the total number of particles 79 and charge on the single particle 1.6 into 10 raised to minus 19 coulombs. Therefore total charge on nucleus equals to Z into E. This is nothing but Z. Atomic number is nothing but Z. So Z into E. So therefore Q equals to Z into E. Q equals to Z. What is the Z? 79 multiplied by charge on the single particle 1.6 into 10 raised to minus 19. Therefore this is the total charge. Here what is the particle here? The particle is nothing but proton present at the center of the atom, that is nucleus. So there are the 79 protons and charge on the single proton is 1.6 into 10 raised to minus 19 coulomb. Therefore the total charge on the nucleus is Q equals to 79 into 1.6 into 10 raised to minus 19. This is the coulombs. We need to find electric potential now due to that all charges. Okay, so electric potential. What is the formula for electric potential? That is a V equals to 1 upon 4 pi epsilon naught multiplied by Q upon R. We are having R value. What is R value? R is nothing but 6.55 into 10 raised to minus 19 meters. This is the R value. So now going to put these values here, and by putting all these values, simplify, we get the electric potential. Therefore V equals to 1 upon 4 pi epsilon naught Q nothing but 1.6 into 10 raised to minus 19 multiplied by 79, and R value 6.55 into 10 raised to minus 15, and 1 upon 4 pi epsilon naught nothing but 9 into 10 raised to 9, 1.6 upon 6.55 multiplied by 79 here, 10 raised to minus 19 plus 10 raised to 15, and even so 9 into 1.6 into 79 divided by 6.55 into 10 raised to minus 19 plus 15 and plus 9, this value here. So this is a plus 9. After that, if you simplify this, you will get 1.7367 into 10 raised to 7 volt. So what is the formula for electric potential? The electric potential formula nothing but given by 1 upon 4 pi epsilon naught into Q upon R. You remember this formula for electric potential due to the charge Q is given by V equals to 1 upon 4 pi epsilon naught into Q upon R. This is a very unique formula. You have to remember it. Here is a electric field. E is the electric field. Electric field is given by 1 upon 4 pi epsilon naught into Q upon R square. and we know that 1 upon 4 pi epsilon naught q upon r, this can be written like this. Here is a 1 upon r. Therefore, E equals to 1 upon 4 pi epsilon naught into q upon r is nothing but V. So V upon R implies the relationship between electric field and electric potential is given by V equals to E into R. Even this formula is quite easy. Only there is a difference of R between electric potential and electric field. Example number 2. Two charges, 1 into 10 raised to minus 9 coulombs and minus 2 into 10 raised to minus 9 coulombs are separated by 0.1 meter. At what point on the line joining the two charges electric potential is 0? Everything is 0, mere bhai. How to do this question? Okay? How to do? Sab kuch 0. Why the problem is given when everything is 0? No problem. So let us draw. Let us draw here the two charges. Here is the Q1 and here is the Q2. We got the two charges here, Q1 and Q2, and the distance between them 0.1 meter. Now line joining Q1 Q2, there is somewhere at some point, okay, the electric potential is 0. So let us call this point as a A, and this is a point B, and it is a point C. And from Q1, let us say it is at a distance of x, and the total distance is nothing but 0.1 meter. So this distance is equals to 0.1 minus x. Okay, so distance AC equals to x and distance CB equals to 0.1 minus x. They are in meters. And Q1 and Q2 given. We need to find the value of x, the Q1 value, Q2 value given. Line joining A and B. There is some point C where electric potential is 0. Okay, so everything is 0 at point C. We need to find the value of x. How are you going to find? Very easy. So let's say the electric potential due to the charge Q1 is V1 and electric potential due to charge Q2 is V2. Now we will find out electric potential at point C. To find electric potential at point C, due to Q1, that is a V1 equals to 1 upon 4 pi epsilon naught Q1 upon x. And after that V2. Okay, how to find out V2? Electric potential. What is V2? V2 is nothing but electric potential due to charge Q2 at the point C. So electric potential due to charge Q2 at C, that is V2. So V2 equals to 1 upon 4 pi epsilon naught Q2 divided by distance. What is the distance between BC? That is the distance CB equals to 0.1 minus x. So what will come here? 0.1 minus x. So we got the two potentials, but the addition of V1 and V2 is 0 at the point C. So at VC, electric potential is 0. So what we'll do now? We'll add V1 and V2. So V1 plus V2 equals to 0 because it is given in the question itself. The electric potential at point C is 0 due to both the charges. So what is the V1 value? 1 upon 4 pi epsilon naught Q1 upon x plus V2, that is 1 upon 4 pi epsilon naught Q2 upon 0.1 minus x, that is everything is equals to 0. What is the Q1 value? This is the Qn. Q1 equals to 1 into 10 raised to minus 9 coulombs, and it is Q2. What is the Q2 value? Q2 equals to minus 2 into 10 raised to minus 9 coulombs. So we will put this value here in this equation. Before putting these values, what I will do, I will take this common. So Q1 upon x plus Q2 upon 0.1 minus x, this is equals to 0. So q1x plus q2 upon 0.1 minus x equals to 0. Now after this we can put the value of q1 and q2. So q1 value 1 into 10 raised to minus 9 upon x, and q2 value minus 2 into 10 raised to minus 9 upon 0.1 minus x equals to 0. So 1 into 10 raised to minus 9 upon x equals to minus 2 into 10 raised to minus 9 upon 0.1 minus x. Both sides 10 raised to minus 9 get cancelled. Now we need to solve this equation. One mistake, there is a one mistake. When it goes that side, it becomes minus. So mistake is corrected. Therefore we get 1 upon x minus into minus equals to plus 2 upon 0.1 minus x. Cross multiplication. When you do cross multiplication, what will happen? When you do the cross multiplication, it will 0.1 minus x equals to 2x. So when you solve this, what will happen? 0.1 equals to 2x plus x. So 3x equals to 0.1, x equals to 0.1 divided by 3. So this is equals to x equals to 0.033 meters. This is required solution. Third example. In this example, 3 charges are given and we need to find electric potential. So let us read the question. 3 charges of 2 into 10 raised to minus 9 coulombs, that is the first charge. 3 into 10 raised to minus 9 coulomb, that is the second charge. And 4 into 10 raised to minus 9 coulomb, that is the third charge, are placed at the corners of equilateral triangle of side 60 centimeters. Calculate potential at a point equidistance from the vertices of triangle. Okay, so we need to find electric potential here, and 3 charges are given, and the point is equidistant from all the 3 vertices. So let us first draw the diagram. So we got the diagram here. Let the triangle ABC, and at A the charge Q1 is placed, at point B the charge Q2, and at the vertex C the charge Q3 is placed. What is the Q1 value? 2 into 10 raised to minus 9 coulombs. What is the Q2 value? That is 3 into 10 raised to minus 9 coulomb. And what is the Q3 value? 4 into 10 raised to minus 9 coulombs. And the side of the triangle is 60 centimeter. So call it the length BD will be equal to 30 centimeters. And it is an equilateral triangle. Therefore this angle is equals to 30 degrees. And point O is the equidistance from vertex A, vertex B and vertex C. Let us call this distance, equidistance is the R. R is the distance. R is the distance. That means distance AO equals to distance BO equals to distance CO equals to R. We need to find electric potential at the point O. First of all, we need to find the value of R. So how to find out of the R? So for that we can consider the triangle BDO. So 30 centimeters equals to 30 upon 100 equals to 0.3 meters. Now we have the two sides BD and OB. So we need to find the value of R. For that we need to use trigonometry. So we have the two sides, adjacent side and hypotenuse. Therefore I am using cos theta. Cos 30 equals to adjacent side upon hypotenuse, that is BO. So BO we need to find out. BO nothing but R. Therefore R equals to BD upon cos 30. R equals to BD. BD nothing but 0.3 meters. Cos 30 root 3 by 2 equals to 0.3 into 2 upon root 3. So R value equals to 2 into 3 upon 10 into 1 upon root 3. R value 2 into root 3 into root 3 upon 10 into root 3. Root 3 gone. So R equals to 2 root 3 upon 10. And it is in meters. We can cut it. 2 ones are 2 5s are. Therefore R equals to root 3 upon 5 meters. After that, we need to find electric potential due to individual charges. That we need to find V1, V2 and V3. So V1 is the electric potential due to Q1 and V2 is the electric potential due to charge Q2 and V3 electric potential due to charge Q3. We need to find out V1, V2, V3 by applying the formula 1 upon 4 pi epsilon into charge upon distance. So V1 equals to 1 upon 4 pi epsilon naught Q1 upon R and V2 equals to 1 upon 4 pi epsilon naught into Q2 upon R and V3 equals to 1 upon 4 pi epsilon naught into Q3 upon R. Now total potential at point O, V equals to addition of all the three potentials, that is V1 plus V2 plus V3. Therefore V equals to 1 upon 4 pi epsilon naught Q1 upon R plus 1 upon 4 pi epsilon naught Q2 upon R plus 1 upon 4 pi epsilon naught Q3 upon R. This is equals to, we can take 1 upon 4 pi epsilon naught common as well as 1 upon R common. So in the bracket we got here Q1 plus Q2 plus Q3. Therefore V equals to 1 upon 4 pi epsilon naught. The value of this is nothing but 9 into 10 raised to 9 and R value nothing but root 3 upon 5. So 1 upon root 3 upon 5 and putting here Q1 value, that is 2 into 10 raised to minus 9 plus Q2 value 3 into 10 raised to minus 9 plus Q3 value, that is 4 into 10 raised to minus 9. So V equals to 9 into 10 raised to 9 into 5 upon root 3, 10 raised to minus 9 common, 2 plus 3 plus 4. So this is equals to 45 into 10 raised to 9 upon root 3 into 10 raised to minus 9 into 9. 10 raised to plus 9 minus 9 get cancelled, equals to 45 into 9 upon root 3. This is equivalent to, here is a trick, that is 1 upon root 3 equals to 0.577. So approximately equals to 0.58. You learn this value, 1 upon root 3 equals to 0.58. So 45 into 9 into 0.58. So this is equivalent to 234.9 volt. Therefore electric potential at the point O is nothing but 234.9 volt. This is required solution. If I don't consider 0.58, if I just consider 0.577, then this result, this number 234.9 will vary little bit. So electric potential at the point O is roughly approximately 234.9 volt. Now example 4, a cube of side 1 meter and root 3 into 10 raised to minus 9 coulomb of charge placed at each vertex. Find electric potential at the center of cube. Okay, it is little bit different compared to earlier three problems. Here we got the cube and at every vertex of cube, the charge of root 3 into 10 raised to minus 9 coulombs is placed. We need to find electric potential at the center of the cube. Seems to be tough. Let's see, is it really tough or can be done in very easy way. Before proceeding, let us draw the diagram of the cube. So this is the diagram of the cube and their vertices. Now draw the diagonals AD and EB and their intersection point is O. O is the center of the cube. Let A be the side of the cube. Every side is equals to A. So we need to find AD. AD is given by under root of A square plus A square plus A square equals to A root 3. And O is the center of the cube. Therefore, AO is half of AD. Therefore, AO equals to root 3A divided by 2. Now, at every vertex, a charge of root 3 into 10 raised to minus 9 coulomb is placed. At vertex A, root 3 into 10 raised to minus 9 coulombs. At vertex B, even same charge, 10 raised to minus 9 coulombs. At vertex C, root 3 into 10 raised to minus 9 coulombs. Like this, at every vertex, we placed a charge of root 3 into 10 raised to minus 9 coulombs. And the distance OA equals to distance OB equals to distance OG equals to distance OF equals to OE and equals to OD and equals to OC. So we need to find out electric potential at the point O. Since all vertices are equal distance from center of the cube and this distance is equals to R equals to root 3A upon 2. Now if suppose we place a charge Q, then what will be the potential? Let us say potential equals to 1 upon 4 pi epsilon naught into Q upon R. So this is the potential due to the charge placed at the point A. This is the potential at the point O due to the charge placed at the point A. Okay, we can later on remove this suffix. So here 1 upon 4 pi epsilon naught and Q as it is. What is R value? R value root 3A upon 2 equals to 9 into 10 raised to 9 into Q into 2 upon root 3 into A. So there are the 8 corners, 8 vertices, and so total potential V is nothing but potential due to point A, potential due to point B, point C, and so on till the last point VH. But every potential is equal, therefore the equivalent potential, the final total potential is nothing but 8 into VA because they are the 8 points, 8 corners. So this is equals to 8 into 9 into 10 raised to 9 into Q into 2 upon root 3 into A. It is given that the side of the cube equals to 1 meter, that is A equals to 1 meter, and every charge has a value of root 3 into 10 raised to minus 9 coulombs. Therefore here 8 into 9 into 10 raised to 9. Q value nothing but root 3 into 10 raised to minus 9 into 2 upon root 3, and A value nothing but 1 meter. Now let's see the cancellation. Root 3 get cancelled, 10 raised to 9, and this also get cancelled. So this is equals to 8 into 9 into 2. So that is equal to 72 into 2 equals to 144 volts. 144 volts. Therefore, electric potential at the center of the cube, here is the electric potential, is nothing but 144 volt. So this is required solution. So that's all in this video. I hope after going through this video, you will be able to solve the problems related to electric potential from your textbook. I request you start solving questions from your textbook. If you are not getting them, if you have some difficulty, please suddenly contact me on my email address provided in the description box. I will help you. Also write down your comments so that I come to know how much you are understanding, how much this video is benefit to you. Meet you again with another topic. Before saying goodbye to you, I would like to request you like, share and subscribe the channel. Meet you again with another topic. Till then, wish you good luck. All the best.